going to talk about parallel and perpendicular lines. Here's our warm-up. Go ahead and pause the screen and complete this. Determine what form the equation is in and find m and b. So this is from last lesson, and this one is in slope-intercept form. Slope-intercept form is nice because it shows us that this right here is the slope, m, and negative 15 is b, the y-intercept. Looking at number 2, this one does not have the y by itself, so I can tell that this one is in standard form. In this case, it wants us to find the slope and the y-intercept, so in order to do that, we need to get it back into slope-intercept form. So to do this, we need the y to be by itself, so we're going to minus the 4x on both sides. We end up with 5y equals negative 4x plus 20. Divide by 5, and we get y equals negative 4 over 5x plus 20 divided by 5 is 4. So here, the slope is negative 4 over 5, and the y-intercept is 4. Let's go ahead and start our lesson on parallel and perpendicular lines. At the end of this lesson, you should be able to determine if two lines are perpendicular, parallel, or neither. Take a minute and write this in your journal. Here are a couple properties of parallel lines. Parallel lines have the same slope, meaning that m is the same. Perpendicular lines, however, they intersect. The slopes are opposite reciprocals. We'll explain that in a minute. And the product of the slopes is equal to negative 1. Let's go ahead and look at a few examples. Are these two lines parallel or perpendicular? Make sure to write this in your notebook. So equation 1 says y equals 2x plus 5, and equation 2 is y equals 2x. We can pretty quickly see that they have the same slope. The coefficient before the x, the slope, you can see here is 2, and then the second one is 2. Both of them have a slope of 2. So yes, these are parallel since they have the same slope. Pretty quick check there. Let's look at a graph and see if we can determine if these lines are parallel or perpendicular. Really quickly, we can see that the lines intersect. So these lines are definitely not parallel. We want to see, though, if the lines are actually perpendicular. We need to find the slope of both lines. So the slope of line A. Let's go ahead and look here. We know that slope is rise over run. So doing a slope triangle, let's see how much we're rising and running between the 2 points. In this case, we're going up 1, 2, 3, and we're running 2. So the slope of A is 3 over 2. And looking at B, we'll do a slope triangle, and we can see that this is going down and over, so it's going down 2, and it's going over 1, 2, 3, negative 2/3. So let's do a check. Are these slopes opposite, reciprocal? Opposite would mean that one is positive and one is negative, so that checks out. Let's go ahead and write this down so we can be sure. Opposite, reciprocal. So opposite checks out because one is 3 over 2 and the other one is negative 3 over 2. Reciprocal would mean that it's flipped. So in this case, the 3 is on the top, and in slope B, the 3 is on the bottom. So yes, they're opposite reciprocal. Do one final check and see if 3/2 times negative 2/3 is equal to negative 1. That was our last check. 3 times negative 2 is negative 6. 2 times 3 is 6. Negative 6 divided by 6 is negative 1. So yes, these are definitely perpendicular lines, which means they intersect in a right angle. Okay, let's go ahead and do one example here. It says write an equation for the line perpendicular to MN that contains point P. So we need to write a new equation for a line that's perpendicular to MN. So here's our steps. Step 1, find the slope of the given equation. So the given equation is 2/3 x. So the slope of this would be 2/3, the coefficient right before the x. Second step, find the perpendicular or parallel slope based on step 1. In this case, the directions say to do a perpendicular line. So in order to do perpendicular, we need to find the slope that is opposite and reciprocal. So the new line, so I'm going to write the new line is going to have a slope opposite, so we need negative, and reciprocal, flip it, 3/2. Step 3, use point-slope form and substitute your given point and slope found in step 2. Point-slope form, so we have y minus y1 equals mx minus x1. And substituting here. So here's the point that we're talking about, that they want the line to go through. So here's my x1 and here's my y1 to plug in. So I have y minus y1 is 6 equals the slope of my new line. So I'm using negative 3/2 equals x minus x1 is also 6. And lastly, step 4, it says solve the point-slope form. So that is in slope-intercept here. So I need to do a little work so that it's in slope-intercept form. So I have y minus 6 equals negative 3/2 x minus 6. Slope-intercept form has the y by itself. So before I move this negative 6, I need to distribute here. This is negative 3/2 x. Negative 3/2 times negative 6. Let me put the work over here. I'm going to put a 1 on the bottom here and multiply straight across. 3 times 6 is 18 over 2 times 1 is 2. 18 divided by 2 is 9. So negative times negative is positive 9. And last, move the 6 over, so add 6 to both sides. I get y equals negative 3/2x plus 15. And there is my final equation of the new line, which is perpendicular to the line that they gave me. We can see that the slopes are opposite and reciprocal. That's our lesson for today. Here is one you try. Go ahead and find this equation, and I'll see you in class tomorrow.